There's two types of charge that we discussed already. There's the proton, which is positive charge, and the electron, which is negative charge. Now the question is, how do we give something a net charge? How do we take something and make sure it has an overall positive charge, or make sure it has an overall negative charge? And there's three ways to give an object a charge. The first way to give an object a charge is through friction. This is the most common way that we typically give something charge. If you ever have brothers or sisters, a lot of times you rub your feet on the carpet and that gives you a charge, and then you shock somebody, that brother or sister, as well. So with friction, what happens is you simply rub two objects together. One object will get a positive charge, and the other object will have an equal amount of negative charge, and that is due to conservation of charge. So let's say that we have a balloon, and we rub some kind of a fur on it. What's going to happen is the balloon will get a negative charge, and the fur will get a positive charge, equal in magnitude, which is, of course, it's positive instead of negative. So that is the first method of charging an object, probably the simplest way of charging an object. The next one is contact, also known as conduction. This is when you touch an object with a charge, and it ends up that you get the same type of charge as the object that you touch. Most times we come across this with the Van de Graaff generator. So the Van de Graaff generator, that giant metal ball, and there's a belt that then runs through this tube, and that gives this object a charge, which is a negative charge. A lot of times what we do is we have somebody touch this charge, or touch this Van de Graaff generator. And so what will happen is then, usually their hair will stand up one end. And the reason that their hair stands up is because when they touch the object that has a negative charge, they get a negative charge as well. So their hair gets a negative charge, and negatives repel each other. And so all their hair repels itself, and it stands up on its own. The last method of charging is through a process called induction. And this is a method of charging without contact. So there is no touching. There's also no charge jumping from one object to another. So you would not see any sparks in this situation either. In order to do this, first thing we do is we polarize an object. It's going to be a conductor that we polarize, and then we ground that object. Now we have to understand what it means to be polarized though. To polarize an object means that the charges separate so that there is a net negative charge on one side and a net positive charge on the other side of the object. The total charge though is still zero, so it's not a method of charging. So this is not what we are doing here. We're not charging the object, we're simply separating the charge. So objects could be attracted to an object due to this polarization. So you want to be careful. Just because something attracts something else does not mean that they have opposite charges. It could mean that they were polarized. So let's look at, let's say you give a balloon that negative charge, and now you bring it near a wall and it sticks to the wall. The reason it sticks to the wall is because the balloon pushes the electrons deeper into the wall. And it's always the electrons that are moving within an atom. If you were to move around protons, that actually change the chemical makeup of the atom itself. You can't just remove a proton from an atom. It would actually turn it into a different element. So the electrons, more specifically the valence electrons, are being pushed further into the wall, leaving a net positive charge at the surface of the wall. Notice that the wall is not charged. The wall has a total charge of zero, many positives and negatives. But because the positive charge is closer to the surface, the balloon is attracted to it. So polarization could attract objects. So we want to be careful. Just because two objects are attracted does not mean that they have opposite charges. One of the objects could be polarized. This is why whenever you try and throw away a piece of candy wrapper, it tends to stick to your hands. You know, those Reese's peanut butter cups, you try and throw those wrappers away and they always stick to your hand. And the reason is because the wrapper itself is polarized. Now, with induction, what we're going to do is we're going to take a charged object, The one object has to be charged to begin with, and so we can take our Van de Graaff generator, and that Van de Graaff generator has a negative charge. And then we can take a conductor. A conductor would be a metal where the charge can easily flow through. And insulator is the opposite of conductors. We have conductors where the charges flow easily through, and insulators which do not allow the charge to flow as easily. So this would be a conductor, would be another piece of metal. And just being near this Van de Graaff generator, just being near this charged object, is going to polarize it. Drive the electrons to the other side and leaving a net positive charge closer to the Van de Graaff generator. Now this object is not charged yet. So what we're going to do next is we're going to ground this object. So we're just going to run a wire into the ground. So that's our universal sign for grounding. This will allow the electrons to go even further away. So right now they're bound by the limits of the object itself, of the conductor itself. Now we have a wire where those electrons can now leave and go through the wire into the ground. Now we remove that wire, and so the electrons cannot come back, and this leaves an overall positive charge on our conductor. And so with induction, we give the object the opposite charge as the one that it's been near, but no charges have jumped across. We've simply polarized it and then grounded it to allow it to gain a negative, or the opposite charge of the object that was near. So again, there's three methods of charging. Friction, the most common. Contact, let's say you touch a bare wire, you get a charge as well, so that's through contact. And induction, this is a method through polarization and then grounding. And polarization is not a method of charging, but it's simply that we have separated the charges. So net positive on one side, net negative charge on the other.